In this example, let's consider two-point charges, one 50 microcoulombs, the other one minus 50 microcoulombs. And we are given 2 points, the point A, which is above the positive charge, 30 centimeters above, and the point B, it's also 30 centimeters above their midpoint. And what are the potentials at the point A and at the point B? Now, this is an example that we had, this is a system that we had also studied before, and before we were required to calculate the electric fields at the point A and at the point B. Now, let's calculate the potentials. The potential at the point A will be just the sum of the potentials created by these charges separately. So it will be the potential created at the point A due to the charge 2 plus the potential at the point A due to the charge 1. And the potential, each one of these charges are point charges. The potentials created by point charges are 1 over 4 pi epsilon 0. The charge, which is Q2, divided by RA2. This is the distance between the point A and the charge 2. Plus 1 over 4 pi epsilon 0. Q1 divided by RA1. Now we can put in the numbers. This constant is 9 times 10 to the power 9 Newtons meters squared per coulomb squared. Q2 charge is 50 microcoulomb. So it is 50 times 10 to the power minus 6 coulombs. Divided by the distance of the charge Q2 from the point A is 30 centimeters. So 0.3 meters. Plus 9.0 times 10 to the power 9 Newton meters squared per coulomb squared. Q1 is minus 50 microcoulombs. So minus 50 times 10 to the power minus 6 coulombs. And the distance of Q1 from the point A is around 60 centimeters. So 0.6 meters. So these are the potentials created by each one of those charges separately. And if you just calculate these numbers, you will see that this is 7.5 times 10 to the power 5 volts. So this is the voltage of the point A. Now let's look at the point B. What is the voltage of the point B? Well, the expression is similar. It's the sum of the voltages created by each one of the charges separately. This is 1 over 4 pi epsilon 0 Q1 over RB1 plus Q2 over RB2. But note that Q1 and Q2, they have the same magnitudes, but they differ in sign. RB1 and RB2, they are the distances of the point B from these two charges. But since we are on the midline separating these two, midplane separating these 2 point charges, the distance of the charge Q1 from the charge B, if it is 40 centimeters, the distance of charge 2 from the point B is also 40 centimeters. So these 2 distances are equal. Q1 and Q2, they have the same magnitude, but they differ in sign. So when you sum them up, it's just 0. So you see that when we were studying the electric field in this system, and when we were trying to calculate the electric fields at the point A and B and their direction, we had to take their components of the electric field separately, and we had to add them vectorially. Here, since the potential is a scalar quantity, it's just a number, we just add the numbers. We don't need to, they don't have any directions. We don't need to worry about them. So the computation becomes much simpler.